This is Jack Jackson. In this video, in this section, we will be finding a t-interval for paired data. For example, some before and after data from the same subjects. One of the most powerful and informative uses of inferential statistics is when we looked at paired data. Now, one of the problems that we have when we're trying to use inferential statistics, especially if we're trying to compare two different data sets, is that there are too many, sometimes we call them confounding variables or extraneous information. And so what happens is too many other things are going on. So if we, for example, wanted to find if weight loss program works, we could take a bunch of people and find the weights of people who are not on the program, and then take a sample of people whose weights are on the program and see if there's a difference. The problem with that is there's too many variables that are going on there if we're not using the same group of people. But one way to control for that is to use paired data. And this makes this very powerful. So we take the same person and we find their weight before entering the diet, let's say this weight loss program, and then after they've done the program and see how much weight, hopefully, that they lost. Okay, and so we may look at that. Now, at first glance, it may look like this is actually two samples. However, what we really have is not two samples at all, but rather one sample of ordered pairs, where each ordered pair has a measurement from the first and second measurements, and they're related and dependent on each other. So sometimes this is called two dependent samples, where it really is just one sample of ordered pairs. So again, one of the most common examples of this is before and after data. So for example, we might want to measure the weight of the same subjects before and after a weight loss program. So for each person, we have two weight measurements. In other words, we have an ordered pair of measurement, weight before, comma, weight after. So what we are typically interested in is not the individual measurements before and after, but rather if the measurements changed and by how much. So what we do in this case is we find the differences in the measurements. Weight after the program minus weight before the program, for example. So we have a single sample of differences. We can then proceed to perform a one-sample inference, t-interval or t-test, on this data set of differences, but it's really just one set of differences. For paired data, we want to find the set of differences by taking the final measurement minus the initial measurement and proceed using one-sample inference methods on this sample of differences. So here's an example of just what we were talking about, before and after data for a group of people who have entered a weight loss program. On the first day of the program, they were weighed. Those are given in that column there, 180 pounds, 225 pounds, and so forth for subject 1, 2, 3, and so forth. After completing 6 weeks of the program, they were weighed again. The measurements are given below. So the person who weighed 180 at the beginning is now 175. The one that was 225 pounds is now 200 pounds, and so forth. And we have 9 subjects. So let's construct a 90% confidence interval for the mean amount of weight change. Assume the distribution of weight loss is approximately normal, so a sample of size 9 is going to be enough to satisfy our normality requirement for the distribution of sample means. And the question is, does it appear the weight loss program is effective? And how much weight are they losing on average? Well, we first compute the differences here. So it's the weight change. A negative here is means that the person lost weight. A positive means they gain weight. That we get that if we do the final weight minus the initial weight. And you can see those are not too hard to even do without a calculator. Or we could do them with a calculator. Now maybe an easier way to do this would be go to our calculator. In L1, say on a TI-84, enter the weights for the before, and L2 in the same order, so that corresponding things are lined up as more or less like an ordered pair here, and put the final weights in L2. Then to get the differences, we're going to put those in L3, and the easiest way to do that is put your cursor on L3 on the label up here. Go all the way up here to make sure that's highlighted. Then just type L2 minus L1. L2 is second 2, and then subtract second 1. Enter, and notice that the calculator did all the subtractions for us and put those in L3. So that saves us having to type in all those subtractions. We do, unfortunately, have to type in all the data. Okay, now we just run our, well, in this case, we wanted a confidence interval. Okay, and so we do our confidence interval with L3 as our data, just a one sample. And the appropriate thing to do is a T interval here. So here we have the same before and after data, and the same thing put it together in a Inspire. So we go to the spreadsheet Inspire. I actually labeled it before and after, and the difference, which was column B minus column A, which we were able to do here. So I think that is clear. You can put labels up here in this very top row, and we put in the second row, right here where it says equals, right below C, we just put B minus A, and it will, and then enter, and it will figure out that below. So now we run our one sample T interval, which is number 8 here on the TI-84. So you press Stat, go to Test, choose number 8, and you choose Data this time, but we're using list 3, not list 1 or 2, but list 3, frequency 1. It's a 90% confidence interval, so it's 0.9 is the confidence level. It'll calculate. It produces our interval here. It also computes X bar. That's the mean amount of weight loss for this 9 people. That's a sample mean. So on average, this particular group had lost about 17.9 pounds, almost 18 pounds on average, with a standard deviation about 15.5, and that's a sample size of N. We're 90% confident that the average weight loss of all people using this program should be somewhere between, say, about 27.5 pounds and 8.3 pounds. Somewhere in there is where we would be 90% confident that any person taking this program would lose if we average them. Okay, so if we were to do averages of a group of 9, then we would be 90%. Well, we use that to construct this confidence interval. 90% of the time, confidence intervals like that would capture the true mean. So we're 90% confident that the people using this program after 6 weeks would lose something in this range. We see the same thing over here on the TI Inspire. On the right side, let's see, we go to Menu, Statistics, Confidence Intervals, T interval. The list was labeled Difference, frequency is 1, confidence level is 0.9, okay, and it produces the same thing. Here are the lower and upper limits. It also produces some other statistics. There's your X bar, your margin of error, the degrees of freedom, the standard error, that's the standard deviation of the X bars, and then the N. So it produces a little more information, but they both produce the confidence level we need. So note that the mean loss of weight loss of people in this sample is 17.89 pounds. The 90% confidence interval for the mean weight change for all people using this program is then, let's round it off to negative 27.5 to negative 8.3, and that's in pounds. Since the interval is completely in the negatives, we can conclude that there is evidence to support the conclusion that the program is effective in reducing weight, and we're 90% sure that the average weight loss after 6 weeks is somewhere between 8.3 pounds and 27.5 pounds. Note that as with all T or Z intervals, this conclusion is about the average weight loss through the program, but it does not make conclusions about individual weight losses. Notice even in this sample, some individuals lost much more than the sample mean of 17.9 pounds, and some lost even beyond the lower end of the confidence interval, more than 27.5 pounds. On the other hand, some individuals, even in one guy or gal, actually increased in weight. We should always be cautious to conclude unequivocally that the changes are due to the program, because there can be hidden variables. However, since the data is from 2 measurements with the same subjects, we can be reasonably sure that the changes are due to the program, especially if we are reasonably sure that no other hidden factors are known. All right, your turn. Let's give you a problem here, an exercise, and see if you can work this one. A group of factory workers are measured to see if their total daily production levels and number of products assembled. A change in production techniques is implemented in an effort to improve the production levels. After receiving this training on the new techniques and practicing them for 1 week, the same workers are then tested again. Construct a 92% confidence interval for the change in production level. Did the program help? Assume that the distribution of changes is approximately normal, so we can get by with a sample size of only 8. Here we're given 8 workers. Their pre-test and post-test matched up on these same workers. Work this out yourself and come back and check your book. Press pause now. Okay, now that we come back, let's take a look at this and see what we came up with. So note that all the conditions for a t-interval are met. We determined that the mean increases in daily production from the sample is 25.5 items per day. We're 92% confident that the overall mean increase in daily production is in the interval 18 products per day to 33 products per day. Since the interval is completely positive, there is sufficient evidence to suggest that the methods were effective in boosting average production level. Here you can see this confidence interval constructed with a TI-84. On the left, L1 is the pre-test before, L2 is the corresponding post-test after. Be sure they're lined up with the same person on the same line. L3 then, put your cursor on L3, type in L2 minus L1, it will do the subtractions for you, which we have listed up here in the table and down here. Run a t-interval with data from L3. Say one sample t-interval, but our interval is our data is the differences of before or after minus before, and then our confidence level and calculate, and it gives you the confidence interval. Here's the same thing on the Inspire. Set up a before, after, and difference column like we did on the last example, and run this and you get the same amount. We'll do some more examples. Next time we'll go on to a 2-sample problem in the next video.